So today we will talk about Jenkins and Terraform integration, right? Where we run Jenkins on a Kubernetes cluster set up inside DigitalOcean cloud. And then instead of using static agents like Linux nodes as build agents, we'll use pods as build agents, right? And we'll also talk about what are the advantages we will get by using pods as build agents. Okay, so we will see how to set up a Kubernetes cluster on DigitalOcean, and then using Helm charts, we will set up Jenkins. Okay, and the service type for load balancer, we will for service type. Okay, and to expose Jenkins, we will use load balancer service type. So once it is done, so we will start to write declarative pipelines. Okay, so using which we will clone repository that has Terraform configuration, and then we'll see how to create infrastructure using Terraform. So we'll make use of Kubernetes pods as build agents for this. And then finally, we'll see how to trigger pipelines through webhooks. Okay, so the prerequisites are we need to have kubectl and Helm CLI installed in your machine. Okay, and I'll be using VS Code to modify my pipeline. I mean, to write my pipeline. It is optional. You can use any text editor. We also need to have AWS IAM account. Okay, so that Jenkins can talk to AWS cloud to provision the infrastructure. And finally, we need to have DigitalOcean account. So first, let's start with some basics before understanding how to write pipelines and all. Okay, so we already seen what is Terraform in our series. Basically, Terraform is an IAC tool by HashiCorp. It lets you define infrastructure in declarative configuration, right? We know what is declarative and imperative. Imperative means we'll write commands to achieve the end state, right? Correct? But in case of declarative, we will write YAML files. I mean, the files can be anything. But the thing is, declarative means we will not tell the tool how to create the infrastructure, right? So we will just say how the infrastructure should look like. Got it? Then the IAC tool will take care about the rest, like how to connect to the infrastructure like AWS and how to create the infrastructure and all.
Yeah.
Okay, and using HashiCorp configuration language, we will write all the Terraform configuration scripts. Okay, most of the IAC tools like Chef and Puppet, they basically follow master agent architecture, where you'll have a master running and agents running. Okay, but in case of Terraform, Terraform will not have any client server model or master agent model. It basically uses the cloud provider APIs to connect to them and create the infrastructure. Okay, so we can use the a Terraform tool to provide infrastructure in any cloud like Azure, AWS, GCP. Okay, we already seen this in our Terraform sessions. And coming to the Terraform workflow, okay, so you have the Terraform infrastructure code, right, written in HCL language. And then, as we already discussed, Terraform depends heavily on the providers, okay, like AWS provider, GCP provider, Kubernetes provider. Okay, it can be anything. Okay, to create the infrastructure. And once you have the configuration available, so you can use Terraform Init to download all the dependencies like modules and providers. And then we will plan the infrastructure using command Terraform plan. Okay, and then we'll apply the infrastructure using Terraform apply. Got it? Okay, so this is the complete Terraform workflow. So you write the infrastructure and then you plan, like you do Terraform plan. So that will show you what exactly Terraform is going to create, destroy, or modify. And then you apply the changes once you're satisfied. Okay. And we all know that Terraform uses blocks, okay, which are containers for Terraform configuration. So we have Terraform block that will be used to define the providers, right? And also the backend configuration. The default backend is local. You can also define the remote backend using backend. And then you have variables block to define variables. Okay. And then you have the provider block, resource block, data block, output block. So you have a lot of blocks, right? Correct. So if you look at all the blocks, okay, so you will find Terraform block, provider, resource, input, output, data, modules block. Okay, in case if you want to import any module, and then you also have local, okay, which is basically which will define the local variables inside your Terraform configuration. Okay, And coming to the Jenkins, it is an open source automation server, right? That we use to automate all sort of manual tasks related to building, testing, and delivering our software. Okay, it is written in Java and it is portable to all the operating systems. Got it? Since it is based on Java, if you're trying to run Jenkins on any machine, you need to make sure that you have Java. Okay, so the recommended version of Java for the latest Jenkins is Java 11 or 17. Okay, we already covered this part on how to install Jenkins. Got it in many videos, right? But in case if you're running Jenkins as a container or pod, you don't have to have Java installed in your machine, because already inside the Jenkins image, you'll have Java dependency installed. Okay, and coming to the features of Jenkins, it is open source. It can integrate with your version controlling systems to pull the source code before building. And it has extensive plugin ecosystem of more than 2,500. Maybe it can be even more, and also supports master slave architecture to manage distributed builds. We will see that in some time. Okay, security and authentication. So using various plugins like Matrix and role-based access control plugin. Okay, so you can secure your Jenkins. You can limit the access to various groups and individuals. Okay, and it can also notify you in case of any build failures. Okay, using again plugins like email plugin, Slack plugin. Got it? And it has active community that works on a lot of plugins as well. Clear?
Yeah.
So one important thing about Jenkins is it supports master slave architecture, which means, okay, if you have a Jenkins server, okay, it can be a Jenkins pod, it can be a Jenkins container, or it can be a VM where Jenkins runs as a system service. It can be anything. So that is called as a master basically. Okay, you can also run jobs on the master. You can have the user management, plugin management, credentials management, global configuration. We all do this in manage Jenkins option, right? Okay, but the thing is, if you have multiple projects and many people simultaneously use Jenkins, it might load the Jenkins and it may not run pipelines on time, right? Due to resource constraints and all. So that's the reason why instead of running your jobs on the master, you need to set up various slaves, okay, where Jenkins can delegate the tasks. Okay, if I need to run a task, so delegate Jenkins will select one node, the Jenkins node, and then it will run the job here. So instead of running in the master, it is always advised to run it on the slave node. Correct. So let's assume I have defined a Linux node. It's a Linux VM. Okay, like I have a couple of Linux VMs. Okay, now if I have to run a job, okay, I can decide in which node I can run, right? Using node labels. Correct. Okay, I can label the node, and then when I'm writing the pipeline, I can also decide in which node label the pipeline should run, right? So depending on that, so Jenkins is connect to the proper node, and then it will run. So these are all static nodes, okay, and these are always on nodes. Okay, so they will be connected to the Jenkins 24/7 because these are static nodes. You can say take them as EC2 instances. Okay, but the problem with these kind of nodes is the first thing is they are connected all the time. Okay, which means even if you don't have any jobs, they are always connected, so you will incur some charges. The second thing is if I have to run any Golang based job, so this node has to have those dependencies installed. Okay, we already know this, right? In case if I have to run some Java based or Maven based project, you need to have both Java and Maven installed here. Okay, so this is okay. This is again a one time setup. I can do it. But the thing is, if I have to migrate, my whole Jenkins to different cloud, okay, in that case, again, I have to create these static agents with all the dependencies. Okay, let's assume this node is down due to some issue. I need to recreate that node. Again, I have to reconfigure the complete node. Of course, using Terraform configurations or Ansible playbooks, I can recreate nodes with all the dependencies in minutes. But again, that's not the ideal choice. Correct? Then what else I can do? So, okay, instead of having static Linux or Windows nodes, okay, I can go with the containers. Okay, got it? So what I'll do, so here, basically I'll take a VM. Okay, I'll install Docker in this. And for every job that Jenkins wants to run, a container will be created in this VM. Okay, and the job will be executed inside this container, and this container gets destroyed as soon as the job is done. Okay. So what is the advantage? The advantage is this VM is easy to set up because it has only Docker dependency. And the other advantage is, let's say if I need Golang based, build, I'll take I'll take a Docker image that is based on Golang. Okay. So the container will be created using base image as Golang that already has Golang dependency, which means this particular job can run without needing any external dependencies. Got it? Right? Let's say that my requirement is different. My requirement is I need to have some additional dependencies. Then what I'll do, I'll create a new Docker image with all my required dependencies, and then I'll create the container based out of that image to run my job. Got it?
Yeah.
That's the advantage. Okay. So in this case, what I have to do, if I have to migrate to any cloud, all I will do is I'll create a new node with Docker install, and I'm good to go. Okay. In case if you don't want to create or maintain a separate VM, you can always opt for managed container services like EKS. Okay. So where Jenkins can create containers on the fly using ECS services. Okay. And you have other options. So instead of using containers as agents, I can also use pods. Okay. So there is again another advantage with using pods. So what is that advantage is, okay, let's say my particular pipeline has let's say 10 stages. Okay, each stage requires certain dependencies. Like first stage might require Git dependency, second might require maybe Golang, third might require something else like Java or something else. Okay, so there are a lot of dependencies. So if I use container based services to create a container to run my job, that container image may not have all these required dependencies. Okay, of course I can create a container image with all these dependencies, but usually the size of that container image will increase. Okay, when size increases, creating a container to run that job, okay, for pulling the image and then creating the container, it takes time, right? Got it? In case in future, if I need some other dependencies, again I need to modify that container image or generate a new one. Okay, it is not at all easier task, and it is not at all suggested. Instead, what I can do is, instead of using containers, I'll create a pod for my job. Okay, so what is the advantage with the pod is I can have multiple containers in it. Okay, and my whole pipeline, the single pipeline, can now entirely in this pod. And other advantage is I can decide which stage has to run in which container. Okay, let's say this Git stage, I want it to run in container C1. Okay, and this container C1 is based on Git Docker image. I will do it here, and I will take another container image C2, which is based on Golang image. Then the second stage, which requires Golang dependencies, I will try to run it in C2. Okay, similarly C3 and C4, I can create n number of containers for my stages. Let's say if Git and Golang can run both on a same container, I'll use C1 for both of them. Got it?
Yeah, like multi-container pattern, right?
Yes. Okay. So now my entire pipeline will be completed in a single pod, and once the pipeline is completed, this pod will be destroyed. Okay. So you must be wondering, let's say that Golang, let's say Golang stays runs in C2, my Git is running in C1. So inside this Git container, I downloaded some source code. Now I need to build that source code in C2 container. Okay, but inside C1, your source code is there. How can C2 will run that or build that source code? Okay, so for this reason, okay, if you are going for Kubernetes pods as build agents, so an empty dir will be created. Okay, and this empty dir is shared for all the containers, which means every container has a common shared storage or a volume. Got it? So which means whatever each container is doing, other containers can access it. Okay, clear?
Yeah.
Okay, how this is possible is, see, every container has a workspace directory. Okay, so this workspace is common for all. Okay, so if you are running git clone in C1, it is cloned into a specific workspace directory. Okay, right? And
Yeah.
this empty dir is also mapped to that workspace directory. So whatever content this C1 is doing in the workspace, that is available in empty dir, and it is available to the other containers. That is the advantage. Okay, got it?
Yeah. Yeah.
Now, a few more points about using pods as build agents. Okay, the thing is, whenever Jenkins master pod creates an agent pod for building, okay, so you need to define, how many containers you require. Let's say inside the Jenkins pod, I define 2 containers, but in actual, you will see 3 containers when you look at the agent pod. The reason is Jenkins requires a means of connecting to the agent pod. Okay, it cannot connect to the containers that you have defined like C1 and C2. Instead, for every pod it creates, it also inserts a container known as JNLP. This is the default container based on I think it is JDK, open JDK image. Okay, it is also, I think the image is Jenkins inbound agent. Okay, I'll show you that once I provision the cluster. Okay, so this image is Jenkins inbound agent image. The container runs that image. Okay, so the role of this container is to connect to the Jenkins master through JNLP protocol on port 50,000. Okay, got it? So many people, wonder when they just run Docker container, they'll see 2 ports, port 8080, and they'll see another 50,000 port. Okay, the reason that 50,000 port is required is for JNLP protocol. I'm not talking about pod and all. Okay, even in case if you have a static Linux node, okay, there are multiple ways this Linux slave node can connect to the master. It can be to SSH, it can be to JNLP as well. Okay, if it is SSH, it uses port 22. If it is JNLP, it uses 50,000. Got it?
Yeah.
Okay, so now if you look at the agent pod, okay, if you define 2 containers, so you'll see third one. Okay, that's the default one, so which will be used to talk to the master pod. Got it? Okay, now let's see the whole pipeline, what we are going to do. Okay, so first we are going to we already have a repository that has Terraform configuration. Okay, so it is a simple configuration that creates an EC2 instance in AWS. Okay, that's it, nothing major, nothing complex.
Okay.
Okay, so that is available inside your Git. Okay, right?
Yeah.
Now what Jenkins can do, Jenkins can actually pull that particular Terraform configuration, and using Terraform CLI, it can actually create the infrastructure in the AWS. Okay, and since we are using Kubernetes pods as build agents, so what Jenkins will do is, first Jenkins will create a pod that has multiple containers depending upon the use case. Okay, probably one container will pull the source code, and the other container will actually use Terraform to apply the infrastructure. Okay.
Yeah.
And here, so there are 2 things you need to take care. One is state file. Okay. So if state file is not there in the local repository, if state file is there, let's say if you use local backend, okay, which means the state file will be stored locally, right? Which means if C2 is running Terraform init or Terraform apply, so it stores everything like the state file, dependencies, log file, right?
Yeah.
But this pod itself is not permanent, which means every time you initiate a new job, your state file will be gone, because it is a new pod and a new environment every time.
Yeah.
Clear?
Got it.
Understood?
Yeah.
Okay. Hello.
Yeah, Vikram. Got it.
Okay. So there are multiple ways you can solve this. Okay. So first thing is, okay, I don't recommend this way. So basically you can use a PVC and then you can mount it into the container. Okay. So that's the different method. It is not at all recommended. Okay. I think that's not the correct way. So the other way is you need to have the remote backend. Okay. So
Yeah.
inside the remote backend, you'll have S3 to store the state file and DynamoDB for the state locking. Okay, which we already seen. Okay, clear?
Yeah.
Okay, now let's see the repository, what I have, and what we are going to do. Okay, so this is a repository. So basically it is now private. I'll make it to public after this video. Okay.
Yeah.
So it has a very basic configuration. I have main.tf. Okay, and a resource called AWS instance with the local name web. Okay, it will create n number of instances depending upon this instance count. Okay, that is defined in variables .tf. Okay, and then we have AMI and instance type and some tags. Okay, if you look at the variables, so here I have variable which is of type number, AMI of type string, and instance type of type string. And Terraform.tf asks to supply the variables. Instance count is 1, AMI is this, and then this is the instance type. Okay, and coming to the providers, this is important. So the required provider is AWS provider, okay, of 5.22.0. Okay, so you need to remember one thing. You also need to upload your Terraform dependency log file. Okay, so that people will use the same version every time when they run this Terraform configuration. Okay, and the provider configuration, inside provider configuration, I have reason set to yes east 1. Okay, and then this is important, I have backend S3. Okay, so where so this is the S3 bucket to store the state file, and this is the DynamoDB table for the state locking. Got it? It's a simple Terraform configuration. Okay, and so I'm logged into my AWS console. Okay, I'll tell you why this is required, because I'll be browsing the infrastructure inside AWS. Okay, and I have DigitalOcean Cloud. Okay, so if you go to digitalocean.com, you need to sign up for a free account, and then they'll give you some $100 to $200 for 2 months to try all the services. Okay, clear?
Yeah.
And if you once you sign up, if you come to the dashboard, so this first project is already created for you. So otherwise, I think they'll ask you to create your first project, because everything, every resource that you create, it should be inside a project. So otherwise, you can create a new project. Okay, but first hyphen project is a default project that is already created for everyone. Okay, if not, create a new project. And once you're in the project, so I can go to this Kubernetes. Okay, to create a Kubernetes cluster. Okay, so let's create a Kubernetes cluster. Okay, so the reason, it is your choice. Okay, in fact, I can select a reason which is close to me. Okay, anyways, I have my free trial limit, so it's not at all a problem for me. I can run 24/7. Okay, at least for a month. Okay, you can also see here the version I'm selecting is 1.28. Okay, fixed number of nodes. Okay, so basic nodes are sufficient for me, and I'll be using this node which costs me $24 per month. Okay, with 2 vCPUs, 4 GB total. So this is the minimum requirement for Jenkins. Okay, so I'll also open the Jenkins documentation. Okay, so here, while installing Jenkins, you have various methods like Docker, Kubernetes, Linux, Mac OS. Okay, and also there are some system requirements. So in case if you click on Linux, so they'll show you the minimum requirements. Okay, so I'll click on Kubernetes because we'll be deploying on Kubernetes. Okay, and that too will install it through Helm. Okay, so we will see installing Jenkins with Helm version 3. Okay, let's come back to this later. Okay, so I require just 2 nodes, nothing more than that. And that's it. I don't have to do anything. Okay, so it will cost me $48 per month, which I can easily run for 2 months continuously. Okay, because I need to click on create cluster. Okay, because you'll get 100 USD, right?
Yeah.
Okay, and yeah, that's it. So I already have a readme file. Okay, so using this, I'll try to create the pipeline and do all those configurations. Okay, so here we'll start to create the pipelines and all. Okay, the first thing that we need to do is we need to have Helm and kubectl locally installed, which I already have. Okay, so after that, what we need to do, so we need to add the Jenkins repository, update the local repo, and then you need to actually make some changes, right? Because by default, Helm chart will comes with some defaults like service type. Probably they'll set it as cluster IP, because they might use an ingress controller. But since we don't have any ingress controller, we'll directly expose that service type as load balancer. Got it? So to now to do all those configurations, so first you can pull that Jenkins Helm chart, okay, and then you can extract it. Otherwise, if you use -- untar, as we already know, it will be auto extracted. Got it? Okay, so we'll make some changes and then do Helm install. Otherwise, let's say you don't want to extract and do all those modifications. Simply what you have to do is you have to run this Helm command, because I'm using -- set to dynamically replace the values. Okay, service port, I'm replacing it as 80. Service type, I'm doing it as load balancer. Okay, it's up to you. Okay, you do manual changes and then apply, or directly use -- set to replace it. Got it?
Okay.
Clear? And after that, we will get the initial admin password. Okay, so the initial admin password is available here. So we will log in, we will exec into the Jenkins container, and then we will see that password. Okay, and the other thing is, so we will use pods as build agents. Okay, so if you want to know how to use all those agents, okay, I think you can go to using Jenkins. Not think, I think go to pipeline, using a Jenkins pipeline, and then just a second. Somewhere they have all those. No, this is a tutorial. Uh, Pipeline syntax reference. Pipeline syntax reference. So there you'll have this agent section. Okay, so you can use any agent that is configured in Jenkins, or you can use agent as none in case if you want to define any agent per stage. Okay, or else you can use agent that is um, identified through its label. Okay, you can use containers as agents. Okay, in case if your Jenkins can talk to any Docker, right? Docker node, or else, in fact, you can create a Docker container by first building it and then running your command. Okay, and here you have, okay,
Yeah.
okay, here if you see, so we have agent. Inside that you have a whole Kubernetes manifest. Okay, and
Right.
you have the containers. Okay, and one thing you need to remember is the containers that you're defining should run all the time, which means there should be a command that keeps the container up and running. Okay, so just don't put an image and leave it. Okay, just see, whatever container image you're choosing has an infinitely running process. Otherwise, you replace the CMD or entry point so that the container runs forever. Otherwise, your pod will not start. Got it?
Okay.
And let's say that you have a lot of stages and you don't want to define a particular container name per stage. So you want to, if any stage doesn't define any container, you want that the particular stage to run in a default containers. Then you can define a default container. Okay, so this is basically the container name that you use here. Okay, which means any stage that doesn't define the container name in which it should run inside this Canico container. Okay.
Okay.
Of course, we did not have that default here, but you can use it. Okay.
Yeah.
And also, if you see, I have an example of using pod as build agent. So where this is the pod definition, one container is Terraform. Okay. So if you go to Docker Hub and search for Terraform, you're going to get Terraform image that has Terraform CLI plus AWS CLI installed. Okay.
Okay.
So both are already installed. So you don't have to worry about it. And then since this container doesn't run an infinite command, okay, so that's why I replace the command to be cat. So mostly containers will have cat or sleep, right? If I use
Yeah.
cat and if I don't pass any arguments, which means it will wait, correct? The container,
Yeah.
the process will wait. That's the reason why I have used. And TTY is set to true. Okay, that's obvious choice. That's it. Okay, so now let's go to the DigitalOcean. Okay, and see whether the cluster is okay. So cluster is created. Now what I'll do is let's download this config file. Okay, so I'll download this config file into the same location. Okay, so if you see this file, this is your kubeconfig file. Okay, now I can talk to the cluster. Okay, so there are two ways because I have the kube config with a different name. So what I have to use? I have to supply that to the kubectl using --kube config. Got it?
Yeah. Yeah.
And then k8s, let's say, get nodes. Okay. I don't want to do that. And also this is my local machine. So what I will do is I'll simply cat this file. Okay. And then redirect into which one? Into my user directory, home directory,
Dot cube file.
.cube. I will replace the file called config because that is the default file. Now from now on, I can simply run the commands without, okay, using any --kube config. So my cluster is set. Okay, if you want to explore the cluster, you can explore it. Okay, so the next thing is I wanted to, do the deployment of Jenkins, right? So you can refer this documentation. Okay, whatever we have seen, like installing Jenkins, you need to go to this Kubernetes and then select install Jenkins with Helm v3. Okay, so the same process I have already mentioned it here. Okay, in this README file, the same steps. Okay, so using this Helm chart, basically Jenkins will create a single Jenkins controller, all the relevant RBAC objects like service accounts, cluster role binding, everything will be created. You don't have to do anything. Okay, so first let me add the Helm repository. Okay, I think it is already added. I think it is already added. And then Helm repo update, I've already done it. Okay, so let me search for this. Search all the repositories. Now I have two repositories. Inside the two repositories, there are two different Helm charts. Now Jenkins CI/Jenkins is the Helm chart. Okay, so this is the repository that I have added with this name. And under that, you have Jenkins Helm chart with version 4.8.2. Okay, so what I can do is now I can simply pull it and untar it so that I can modify it, right?
Yeah.
Okay, you can see it is pulled. So what I'll do is I'll simply go to values file and I'll make some changes here. Okay, so I'll not make any other changes except for the port change and the service type. Okay, so service type, it is cluster IP. I'll make it to load balancer because DigitalOcean supports load balancer service type. Okay, and service port, instead of 8080, I need to go to 80. That's it. Okay, so that I can access it directly through the load balancer IP. Other than that, I don't have to do anything. And then using Helm install. Okay, the name of the release I'll use as Jenkins. So if you need to install in any other namespace, just give that namespace name. Otherwise, just give the folder where Jenkins Helm chart is available. That's it. Okay, we already know this process. Now let's me try to get all the pods and services. Okay, so you can see Jenkins pod is running. It is starting. So service type is of load balancer and load balancer IP is pending. It will take some time. Okay.
Yeah.
Okay, so meanwhile, while it is creating, so what we will do is we'll also need IAM user credentials, right? Because Jenkins has to talk to AWS to provision infrastructure. So what we'll do is we'll create a specific IAM account. So go to IAM service of AWS and then click on users and click on create user. So the name of the user I'll use as Jenkins -Terraform, something like this. And I will not provide management access. Click on next. Okay, so I need to give him the administrator privileges. So click on attach policies directly and select this administrator access. Okay, so if you think that Jenkins requires limited access to the AWS resources, then what you need to do, you need to create separate policy. Okay, but this policy is administrator policy. Click on next. Okay, I don't require anything else. Click on create user. Okay, so our Jenkins Terraform user is created. Now just click on that username. Okay, so you can see all the permissions and all that. Now if you go to security credentials, you can activate MFA for him and also create access key and secret access key so that using these credentials, So we can talk to AWS services using AWS CLI or any other scripts. Okay.
Yeah.
Clear? Now I'll click on create the access key. Okay. I'll be using for the command line interface. Okay. And then confirm, click on next, tag I don't have to give. So now you'll get two, one is access key and secret access key. Okay, you should not share them, but for now, okay, so let me simply copy them somewhere so that I can reuse them. Okay, so that is the access key and secret access key, okay, using which I can authenticate with AWS. Clear? Got it? Okay, so I'll click on, let me also download it in case if I need. Let's click on save. Okay, so let's go back and see whether Jenkins is up and running. Okay, now Jenkins is up and running. We also got the load balancer IP, this. So let's copy that load balancer IP and then open it. Okay, so username, initial username is admin. Okay, so how do you find out? Okay, once you install Helm, okay, it will give you this information. Okay, so get your admin user password by running this, but this command somehow is not working as expected. Okay, so what we will do now is we will exec into the Jenkins pod. Okay, so kubectl exec -it. What is the name of Jenkins pod? It is Jenkins-0, right? Okay, and then let's use bash. Okay, so where exactly that password is there? It is cat run where exactly run secrets additional chart admin password. Okay, let me copy this. Okay, so let's copy this and paste it somewhere because we would require it. Okay, and then in the password give it. So I can just change the password. Okay, admin. Oh, 1 second. Did I copy extra characters? Oh, so this Jenkins is
I think you
the
copied
container
Jenkins.
name. Okay,
Yeah.
so we should not copy that. Okay, so if you want to change the password, you can do that by going into Jenkins admin and then clicking on configure, and then you can create API tokens, change the password and all. So I don't want to do that. Okay, because that's not our main aim now. Okay, so unfortunately, it did not ask us what all plugins we need to use.
Yeah.
Okay, so what we will do first is we will see whether we have Kubernetes configured as not for as a cloud agent. Okay, so go to manage Jenkins, go to clouds. Okay, see here Kubernetes is already configured. Okay, because so this is based on Kubernetes deployment. Kubernetes cloud is already created. Now I can click on configure and see how it is configured. Okay, so first is cloud details. Okay, like how Jenkins can talk to Kubernetes to create an agent pod. So this is the URL it uses. So basically this Kubernetes.default is the service name. Okay, so if you let's exit from this container. If you look at this kubectl get svc, so there is a service called Kubernetes in the default namespace. Okay, so this service actually points to the API server. Okay, clear? So
Yeah.
I can directly talk to the API server using this URL. Okay, that is this is FQDN of the service. Got it? Okay, and
Yeah.
so you don't have to do anything here. So one is the Jenkins URL. Okay, that Jenkins runs on port 80, and this is the Jenkins tunnel. Okay, so where Jenkins pod uses to connect to the Jenkins controller. Okay, and now we have pod. Okay, pod configuration. Okay, so why this default pod configuration is required is because Jenkins uses pods as build agents. Now first it need to create a pod with a single container. Okay, so what is that container? If you go to pod templates, so here you'll have details about where exactly pod will run, what is the label of the pod, and coming to the container, as I already said, there is a container called JNLP which will run this image. Okay,
Yeah.
and if you see here, since this JNLP container has to run forever. So there is a sleep command. Okay. Got it. So this is how Jenkins configured the Kubernetes cloud. Clear?
Yeah.
Okay. And yeah, so now what we will do? So we will also see if Git plugin is installed or not. Okay, let's go to the plugins in Manage Jenkins. Okay, I think Git is already there, but there is some update, but that's fine. Okay, go to available plugins. So let's also install, GitHub plugin. Okay. I think this one only, right? This.
Yeah.
Okay, so let's try to install it. On the right hand side you have. Okay, so let's install it. Anyways, it is installing other dependencies as well. So Git is already installed, but GitHub it is going to install. Okay, now let's try to locally. So there is fail to dynamically deploy this. Okay, let's do one thing. Let's restart Jenkins. Okay, now let's start to write the pipeline. Okay, so let me create a new file. Okay, so we can upload this file into the repository, right? In the
Yes.
repository where we have configuration, then Jenkins can automatically read this Jenkins file from the same repository. But for now, I'm just writing this Jenkins file here. Okay, so if you want to know the Jenkins file template, okay, okay, so let's start writing it again. So it starts from the pipeline, right? But and I already have Jenkins plugin installed in VS Code. That's why I can do it. But let's wait, till Jenkins starts. Okay, Jenkins. Okay, sign in. Go to dashboard. Click on new item. It's pipeline. So let's say some name, Terraform. Okay, and click on OK. Okay, so we will configure all the job related configurations later. Okay, so let's first go to the pipeline. Okay, and then here let's click on pipelines, not pipeline syntax. Let's click on something like declarative Kubernetes, something like this. Okay, so it will give you everything. Okay, so let me copy this and paste this in my local machine. Okay, so this is how Jenkins pipeline looks like the declarative syntax. Okay.
Yeah.
So this Kubernetes part, so this is the YAML part. Okay, so which we already have. Okay, so I'll delete this complete YAML. Okay, so default container also I'll remove. Okay, so from the README file, I'm going to just copy this complete, agent block. Okay. Here's a complete agent block. So that is defining, one container as Terraform, other container as Bitnami Git to clone the Git repository. Anyways, third container will be based on JNLP. Okay, that we already know. Correct.
Yeah.
Okay. Now coming to the stages. Okay, so the first stage, what we will use is, which one we will use? Okay, so first we need to clone, right?
Clone Git.
Okay, so clone Git repository. So the first stage is, let's say, check out SCM. Okay, and then what we have to do, we have to open and close this. Okay, so we will write now steps, right? Okay, so here in the steps you can write all the shell based commands, but the problem here is, okay, so we are using container based pod based agents. So we need to define in which container basically these steps should run. Okay, so I want this to run inside a container called as Git. Okay, because if you see, there is this Git container. Got it? Okay. Now inside the Git container, I need to run Git clone and all, correct? Okay. Hello.
We can generate, right? That's what.
Yeah. So let me save the pipeline here for now. Okay. So here, so there is this pipeline syntax generator. Either you can just try to configure the existing pipeline and then click on pipeline syntax, or you can click on pipeline syntax outside. Then it will open the pipeline syntax generator. So we wanted to use Git clone. So let's select Git, and then we need to have repository URL. Okay. So let's take this repository URL. Okay. And then just copy it here. Okay. All it does is it will just create a snippet. The branch is master. Credentials, since it is private, I need to have credentials. Okay. So let me add the credentials. Where exactly we'll add? Okay. So we'll add it in the, we'll go to dashboard, click on manage Jenkins. Okay. And then go to credentials. Okay. Add credentials to the system, global credentials. The type of credential we'll use is username plus password. So the username of my GitHub account is this. Okay. And then password is, I'll try to create a token. Okay. So I'll go to my profile, click on settings, and then we'll go to the developer settings. Okay. Personal access token, tokens classic, generate token, tokens classic. Okay. So I need to authenticate. Okay. So let me use the password for that. And then this token is for, let's say, I can do Terraform or Jenkins. Expiration I'll set it to 7 days. Select the repo. Okay, that's the permissions I need. Generate token. Okay, so I need to copy this token. Okay, so if you go back, that token, you will lose access to that token. Okay, so now in the credentials, as a password, I'll use this token, and as an ID, I'll simply say GitHub underscore creds. That's the ID using which I can identify this particular username plus password combination. Okay, click on token. Now in the pipeline syntax generator, okay, it won't detect it now. Okay, because we need to refresh this page. Then everything you will lose. Okay, repository URL. Again, we will go back and paste it. Okay, and credentials, it is the GitHub underscore creds. Okay, then click on generate pipeline syntax. So this is the code. Okay, so let me explain what exactly it is doing. Okay, so using Git plugin, so it is using these credentials to pull the clone from this. Okay, so here it is not showing the master branch because master is assumed to be the default one. Otherwise, if you select any other branch, okay, let's say something like dev, then in the syntax, it might also include that branch. Got it?
Yeah.
Okay. So this is the first stage. So that is checkout SCM. Okay. So it will pull the, clone, it will, clone it. Okay. So let's see first only till this part. Okay. So let's go back to our manage Jenkins, sorry, Jenkins dashboard. Go to your pipeline, configure the pipeline, go to the pipeline section, remove everything that is already there, and then simply paste it. Okay. Click on save. I think there is some syntax error. Let's go back. No syntax error. Okay. And then click on build now. Okay. Now this is important here. Okay. So it failed. The reason it failed is I think it is expecting some closing bracket. So let's go to our pipeline. So where exactly it is expecting. Okay. So the pipeline block is not closed. Okay.
Yeah.
So basically you need to just indent it to make it look much cleaner. And this is the agent. So agent block, we will indent it. Okay, and this also we will just indent it to like make it much easier to read. Stages should be here per stage. Okay. Go back to your project, click on configure again, pipeline. Let's replace the entire thing, save. and click on build now again. Okay, now if you go to the console output, so here again there is an error. It says hyphen containers inside the Git. Okay, so where exactly is the issue?
In
Hyphen.
stages, I guess. Come here, come down.
Oh, I understood. So here, if you see, we need to indent it properly.
Okay.
Okay, the image command. Uh, okay, clear. Containers, containers. Okay, metadata, labels. This indentation is a little trickier. Okay, AP version kind labels, containers. Okay, I don't know how this is. I think it is taking one tab space. Now everything is clear. Yeah, let's see. Build now. Okay, so it is started by the Jenkins admin. Now you can see it is creating a Kubernetes pod. Okay, so if you look at the pods, you will find a Kubernetes pod. See here, how many containers it is creating? 3. How many you have defined? 2. One is JNLP. Got it?
Yeah.
So now what it will do, it will try to connect once it is created, because it is still trying to pull all the container images, and it will start the containers. Until then, you will find this to be offline. Okay, now you can see the whole pod YAML. Okay, so even though you have added only 2 containers, one is the Terraform container and the other is Git container. Okay, so there will be third container. If you try to see, that is the JNLP container with its Jenkins inbound agent. And also, if you look at the volumes, there is an empty dir, okay, called workspace volume. And if you look at the each container, that volume is mounted under the home Jenkins agent of each container. Got it? So this is how they share a common workspace. Okay, clear?
By default, it will create MTDR, right? We are
Correct. You don't have to do anything. It is already configured.
Okay.
Okay. Now you can see build is successful. Jenkins actually cloned that source code into the Git container because we have used this. Okay. Now what is the next step in the Terraform workflow? The second stage. So it is to initialize, right? So that is Terraform init.
Yeah.
Okay. So what we will do is we will try to run it in the Terraform container, because the name of the container is Terraform. Okay. And here we will replace this whole thing with Terraform init, right? But then it has to be run inside the shell. Okay. So Terraform init. Okay. But the problem here is we have one problem. Okay. This Terraform init needs credentials. Okay. To talk to the AWS. Okay. Because when you're doing Terraform init, if you know, if it is a local backend, it is fine. But if it is a remote backend, it has to talk to the S3 bucket and the DynamoDB table. Correct?
Yeah.
So
Correct.
that's the reason why we need to provide the credentials to it. Okay. So credentials in the sense, the IAM user credentials, which are access key and secret access key. Okay. So if you go to Jenkins documentation. Okay. If you go to Jenkins user documentation, pipeline syntax reference. So there is this blog called environment. I mean, I can supply the credentials through environment variables. Okay. Of course, those will not be exposed in the log or the console output. Okay. So using environment variable, okay, I can actually supply. So basically how to use these environment variables. Okay. You need to declare environment, this block. Okay. And then a name and a key, right? and you can access this CC value throughout your pipeline. Okay, but if you define environment variable per stage, you can only read them in this stage. Okay, so how do you use environment variables to store the credentials? You can see this under the environment variables, but of course they have used it in a stage. If I move this block to the main pipeline block, okay, so those environment variables will be available throughout the pipeline, right? So how they have used this credentials function, okay, or the credentials helper, and then you need to pass the credential ID. Okay, got it.
Yeah.
Okay, so the credential, you can create two different credentials, one to store the access key, the other to store the secret access key. Okay, and then you can pass two credentials. Okay, so one is the access key, and the other is the secret access key. Okay, and then how the Terraform actually requires those credentials. Okay, if you go to Terraform registry and go for AWS provider. Okay, so browse provider AWS and then go to the documentation. Then what they expect is either you provide them into the provider block, but the provider block is in the public repository, right? I can't provide the access key and secret access key here. Okay, so what are the other ways? I can export them. Okay, I mean I can read them from the environment variables. Clear? Okay, with the name called AWS access key, and the other is secret access key, which means, okay, if I go to my pipeline, okay, and if I so let's say after this agent block, okay, so where agent block is ending, it is ending here. Okay, so I'll just take the difference of the environment variable here. Okay, so like CC, I don't require that CC, something like that. I'll just copy this syntax here. Okay, so what is the name I need to use? Okay, if you go to the docs, it should be access key and secret access key, right? Okay, so let me quickly modify it. So I'll use a different method, not this. As an example only, I'm just showing this. Okay, so I can do them like this. Okay, I'll store the credentials. So one is to store the access key and other to store the secret access key. Got it? Clear?
Yeah, Vikram.
And then these values, since they will be used throughout the pipeline, so any Terraform command or AWS command can use these environment variables. Automatically they'll read them and then they will talk to the end service. Okay, but I don't want to use the environment variable here because it is quite risky. Okay, because these are available throughout. Instead, I will use something known as credentials helper. Okay, credentials block. Okay, so what is this credential block is, it will make sure that these credentials are available only for a single block. Okay, for these credentials are scoped actually. Okay, so how do I find that is, let me I think it is with credentials.
Yeah,
Okay,
with credentials.
so this will bind credentials to a function. Okay, now if you see, we can use syntax like this: with credentials, then I'll pass the credentials inside it, and then these credentials are only available within this block where
Got it.
it is opened and closed. So rest of the part cannot access it because it will lose its scope. Okay, now what we
Yeah.
will do is, first we'll go to Jenkins. Okay, and then we'll try to first create the credentials. Okay, go to credentials. Say I don't want to create separate credentials for access key and secret access key. Instead, what I'll do is I'll use username and password. Okay, anyways, username is my this access key, which I can expose it, but it is not useful unless I have the secret access key, right?
Yeah.
So this will be my secret access key. Okay, I can use this combination. Otherwise, what you have to do, instead of kind set to username and password, you need to select as secret text and create two different credentials, one to hold the secret key and the other to hold the secret access key. Got it?
Yeah.
Okay, but I'll use only this AWS creds as the ID. Okay, so I'm using both the credentials under a single name. So that name is called AWS underscore creds. Okay, now let me go to pipeline syntax generator. Okay, so just go to dashboard, open any pipeline, then you'll see this pipeline syntax generator. Let's open it. Then search for with credentials block. Okay, so with credential, what it will do, it will read the credentials and it will bind them to a variable, so I can use that variable to access the secret. Okay, but if you try to print that variable, it won't show that secret. Okay, so bindings. Okay, so what binding I'm using, I want, so I want to use username and password, but both I want to be separated. Okay,
Yeah.
got it. And the credential I'll use is AWS underscore cred, which has a combination of username and password. I want the username to be available with the name called this. Okay, that's my requirement. I want the password to be available with the name as this. Got it. So of course, there are multiple ways you can actually provide them. So this is one of the way I found to be useful. And click on generate. So this is the block it has generated. Now let's go to the pipeline. Okay, so now this particular container, so now you need to enclose the shell script within this block. Okay, so the block is open, so just indent it. Okay, and then try to close this block. Got it. So credential ID is AWS cred. So this AWS access key will have the secret access key will have the password. Okay, username it will have as this. Okay, which means AWS access key ID will have the above information. The secret key will have the this information. Got it.
Okay.
Okay, and then obviously that information is available now for all the commands. So it can be AWS command, it can be Terraform command, because both will read the same credentials, right? Clear?
Yeah. Yeah.
Okay. Now let's so this environment variable is not required because this is one of the ways. Okay, so choose the one which is appropriate. Okay, but for this example we are using this. Now let's try to configure our pipeline again. Okay, and then let's paste it and click on save. Okay, let's click on build now. Okay, now what will happen? So other pod will be created now, right?
Correct. Terraform prompt.
Okay, so another pod with, okay, so why this is, let me refresh this page. Did we click on build now? Now it failed. Okay, it failed because stages, I think some we did not close it properly. Okay, so this is stage. Okay, so let me see it. So this is for the stage, this is for the step, this is for the container, this is for the with credentials, this is for the pipeline. It's correct. Okay, so where exactly we are missing? Let's try to edit it. Configure the pipeline. So did we miss anything?
Duplicate name, Vikram.
Where?
Stage name. Stage name. Both
Oh,
are the same.
stage name is,
Yeah. The error itself shows.
okay, so let's say, oh, error itself shows, I didn't see.
Yeah.
Okay, so Terraform, let's say init. Okay, save, and then click on build now. So let me change it. Okay, the error, I did not see it properly then. Thanks. So Terraform init. Okay, so now it is now creating a fresh new pod. Okay, and then first it will clone, and then it will do git init. And also I need to add options like build discarder and all. Okay, so because I don't want to see it is failure, it says initializing the backend. Okay, yeah. So one more thing I forgot is, okay, so we need to have S3 bucket and DynamoDB table first, right?
Correct.
It is not there yet. So let's go to the Jenkins, sorry, AWS, go to S3, and then just create a file with the same name. Okay. So if it is already there, the bucket is already there, you need to use a different name. because bucket name should be global. Okay, so create bucket. This is the name of the bucket. Choose region as US East 1. Okay, so we don't require anything. So bucket version, enable it. Okay, so that you can see the state file versions and encryption, server-side encryption. That's it. Click on create bucket. Okay, and then search for a service known as DynamoDB. Okay, and then go to DynamoDB, create table. So the name of the table should exactly match this. Okay, so if you're using a different name, then create with that name. Partition key, this also is important. It should be same log ID. It is there in the documentation and we have clearly seen it in the Terraform series. Now click on create table, go to your pipeline. Okay, and just try to build again. Okay, see, there are a lot of logs that are getting populated. I want to use log rotator to delete all the old logs. Okay, and also sometimes what will happen is the Terraform operation might take a lot of time. So I also want to set the global timeout as well. Okay, so for this what I will do is so I'll go to Terraform documentation. Okay, go to pipeline syntax reference. So there is this options block, just like agent environment. There is something known as options. So where you can define build discarder. Okay, and then you can also define the timeout. Okay, retries, quiet period, all those things. Okay, so
Okay.
what I'll do is I'll copy this options. Okay, and then you can put it after the agent block. Option timeout, I wanted to use 1 hour. 1 hour, it's very high, so let me go to put it as 10 minutes. That's fine. And then build discarder, I want to discard old builds, so build discarder. Okay, so I'll say number to keep. Let's say a couple of builds is fine. Okay, 2. So there is also this days to keep. Something other option is also there. Okay, if you scroll to the bottom somewhere, you'll also find. Okay, like how many days you want the logs to be available, that also you can configure. And also timeout. Uh, so retry, if you want to retry, let's say retry count, I can set it as, in case if the pipeline fails, I can also retry. Okay, that's not required for now. Okay, so I have to build discarder and timeout as the global options. Got it? Okay, the same I can also create it in the options, Jenkins option, but I don't want. Okay, so if you go to configure your pipeline, then you have this here, discard old builds, right?
Yeah.
And also there is this quiet period I can also use. In the advanced settings, I think there is also a timeout. Okay, global timeout I can put. I don't want to do this here. I will just do it in the pipeline. Okay, let's see what exactly we have as the console output. Okay, now first thing is git clone is successful. Now Terraform init initializing the backend. You can see it has downloaded the provider, and then Terraform has successfully initialized. Got it? So it is now initialized successfully. Okay, so what is the okay, there is this extra I need to close. Okay, so what is the next thing we will do? Okay, the next thing is we will apply the changes, right?
Yeah.
Oh, just a second. What did I do? Okay, let me.
I think we need to close the stages. Yeah, that's fine.
Okay, everything is proper. Yeah, so now what we'll do is we'll create another stage. Okay, that stage is now Terraform apply. Okay,
Yeah.
got it? And same credential it will use. Now here it will say Terraform what do you say, apply. Okay, so Terraform apply. You can also use auto approve, because anyways see, we will be, why we are using auto approve is anyways, once the changes are only accepted, then only Terraform, this Jenkins pipeline gets triggered, right? Which means there is no point in cross-checking the Terraform plan again. Okay. So we can simply use Terraform apply auto approve. Okay. Got it? Okay. So, but what I can configure in this case is, so I can also define one more called Terraform destroy. Okay. So Terraform destroy also we can write same thing, but Terraform has to apply Terraform destroy auto approve. So shall we include it now? Okay, it is not required now. Okay, because if you put it in the pipeline, so after the apply, Terraform will
It
also
will
do the
delete.
destroy. Okay, but what is the other alternative that I can choose is I will use parameter. Okay, so what is that parameter? So it will ask you whether the action should be Terraform apply or the action should be Terraform destroy.
Destroy.
So where exactly I can use the parameter? See, parameter I can configure it. So if you open the Terraform, your pipeline and click on configure, I can simply say this project is parameterized. Okay, so where exactly is this?
Above.
Yeah, project is
Yeah.
parameterized. Then what I can see, I can select a string parameter. Okay, choice parameter, sorry. I can have two choices like apply and one to destroy. Okay, but here I don't want to configure it from the UI. I will put it in the pipeline only. Okay, so for this, what I will do is, so inside the pipeline syntax reference, there is this parameter. Okay, so I want to use the choice parameter. Okay, so I will use this. Okay,
Yeah.
I'll use this choice parameter. Then let's configure it. So after this option, let's write this parameter block. Okay, I'll move the choices into this new line. Okay, so basically the name I can use as workflow, right? Because it's a workflow. Init is a workflow. Apply is a workflow. Okay, and coming to the choices, apply
Apply or
and
destroy.
then destroy. So I don't have any third. And then description, I can use something like select probably workflow, right? Select
Yeah.
Terraform workflow, something like this. Okay. And now what we will do?
Yeah.
Workflow choice, it is done. Okay. So now this will be available as a variable, right? So here what I will do, instead of apply, I will use string interpolation like this. It's okay. So it is now workflow. Okay. But the
Yeah.
problem is, what is the default one? See, when I run this pipeline manually, okay, so it will ask me whether it is apply or destroy. So, but it should not actually wait for my choice, because if this pipeline gets triggered through a webhook or through a third-party script, they may not send the actual apply or destroy value, right? But if you look at the documentation, they always say the first value is always considered to be default. Okay, which means even if they don't provide, the first value will be considered as the default value. Got it? So
Got it.
I'm pretty sure. So this is like Terraform apply or destroy, let's say like this. Okay, now let's go to our pipeline and then let's replace it. Okay, click on apply and then let's click on build now. Got it?
Yeah. Okay.
Okay, so now okay, so timeout set to expire in 10 minutes. So first it will clone and do git init. Okay, it's failed. Okay, so workflow. Okay, Terraform auto approve. So you did not get the workflow value. The reason is the name is workflow and then the same name, right? Okay, I think we did not refresh this. Okay, so it should be build with parameters. Last time it is
Okay.
simply build, right? You can see two choices, apply and destroy. So the default one should be apply. Okay, and also you can see only last two builds it is showing. Okay,
Yeah.
because those options. Okay, now Terraform apply, you can see acquiring the state lock. Okay, so in our Terraform configuration, so the Terraform.tfvars has only one instance count, right? So which means
Yeah.
it has to create one. And also in the output block, I've uh, trying to print the public IP, all the public IPs of whatever instances that you create. Okay, so it is still creating. Okay, now you can see the public IP. Okay, if you go
Yeah.
to your EC2 console, you will see one EC2 is running. Okay, right now other thing I wanted to do is I wanted to automatically trigger the Jenkins pipeline through webhook. Okay, so whatever changes I make and commit, I want the pipeline to get triggered. So for this, what I'll do is I'll go to my pipeline and configure the webhook. Okay, see this choice parameter, it is already taken from the pipeline, so I did not configure it. Okay, and then enable GitHub trigger for GitHub SCM polling and click on save. Now go back to your repository, go to repository settings and not your user settings, and then click on webhooks. Okay, create a new webhook. Okay, so the webhook payload URL should be which one? Your Jenkins URL, right? Correct?
Yeah.
Jenkins URL, GitHub hyphen webhook slash, and then choose the content type to be application JSON. Okay, and you can send any of the events that happen in this repository to trigger the webhook. Okay, of course you can also select the individual events, like in case only trigger the pipeline if pull request is created and all. So you can select various individual events like PR events in case if an issue is created and all that stuff. Okay, and also for advanced webhook handling, you need to refer my other video on generic webhook trigger plugin, right? How to use it.
Yeah.
Correct?
One of the scenario I saw, Vikram, like after creating a PR, they are
Hmm.
putting some command in that PR.
Correct.
So once we put the command, it will automatically trigger it.
Yeah. Okay. So for now, send me everything. Click on webhook. Okay. And then if you try to refresh this page, you will see that the initial webhook is, successful, which means if you open the webhook and then if you go to recent deliveries, you can see. So an initial ping delivery is sent just to see whether webhook, your GitHub can reach the Jenkins URL. Okay, got
Yeah.
it. Now go back to your repository. Okay, so instead of only one VM, so let me go to terraform.tfvars. Let me change it to 2. Okay, and
Yeah.
then commit the changes. So once it is committed, so it is an event in GitHub, so it has to trigger your Jenkins pipeline. Now, if you see, your Jenkins pipeline is getting triggered, but there is a quiet period. If you go to manage Jenkins, you have this quiet period, right? Like Jenkins has to wait for these many seconds before triggering. Okay, so let's go to the new trigger, and you can see who triggered this. It is triggered by GitHub push. Okay,
Okay.
so it will again create a new pod. Okay, so the default action is apply, so that's the reason why it won't do anything. And the other thing here is you have already state file in S3, which means the previous state is already known to Terraform. Okay,
Okay.
that means already there is one instance created, so it won't try to create two new instances, it will only try to create another instance which is missing. Okay.
Okay.
You can also see in the plan output that this apply command is going to create. So if you see the plan output, it will say, see, only one to add.
Yeah.
Okay.
Got it.
Okay. Because already one IP. Okay. You can see this is the IP. It is already known to it. Okay. Other IP, it is known once it creates. It is not going to create two instances again. Okay.
Yeah.
Clear?
Yeah.
Okay. Now you can see the two IP addresses. Okay. And if you refresh this EC2 management
So,
console, now you'll see two instances. Okay. What about if I want to destroy? Okay. Just go back to your pipeline. Okay. Click on build with parameters and simply select destroy workflow, and then again try to build it. Okay. There is one more thing that you can also do in this case is, okay, so here we are not restricting the pipeline stages depending upon that value. Okay. So which means git clone stage will also run even though it is not required.
correct. Yeah.
Right, because it is a simple destroy plan which will simply needs
Cloning
to.
the GitHub. Yeah.
Okay, Terraform
Terraform
init
and
S3 backend. Okay, it will again download the provider. Okay, so it is destroying. Okay, it will destroy two stages. Okay, so another thing that I wanted to show is, let's say I wanted to display some badges. Okay, so let's say whether the build is passing or build is failing or build is happening. Okay, I want to display a badge. Okay, so for that, okay, uh, let's wait once these instances are destroyed. Okay, then we will see that example. Okay, the instances are destroyed anyways. Okay, so this pipeline will complete. See, destruction complete and pipeline is successful. I want to see that information in my this repository, somewhere that build is successful or failing. So for this, what I'll do is I'll go to Jenkins, manage Jenkins, go to plugins. I will go to available plugins and search for a plugin known as embeddable build status plugin. Okay, so what this plugin will do is it will display these kind of badges. Okay, so these badges can be with a static name, or you can also generate dynamic text based badges. Okay, so how do you embed the status is just select the plugin and simply click on install. Okay, and then if you go to your pipeline, okay, now you'll have this embeddable build status. Okay, so what this will do is it will give you links to show some images. Okay, so what is the link it is showing is, okay, these links. Okay, and these are all the types like flat type, plastic type, and all. Okay, so if you want to put those kind of badges in your markdown file is, so you need to simply copy this. Okay, and also here they are saying one more thing. Okay, see, in case if you want to show the badges publicly, okay, so which means this URL, whoever access this URL should at least have read permissions or view status permission on the particular job. Okay, so if you completely lock your Jenkins, so no one can access this particular URL and that particular status, right?
yeah.
So for this, they are saying at least you need to have view status on the job. So for this, what I'll do is I'll go to dashboard, manage Jenkins, manage plugins, available plugins. I'll try to install matrix authorization plugin. Okay. And then go to manage Jenkins, um, security. So by default, anyone who can log in can do anything. Okay. and the user database is Jenkins own user database. Okay, so authorization, I'll move to matrix, and then I'll say anonymous users only have view status permission on the job. Okay, and let me add a user known as admin, because Jenkins has an admin user by the name Jenkins admin. Okay, so he is the administrator. Okay, similarly you can add users and you can set the permissions on them. Clear?
Yeah.
So now anonymous user, anyone who has link, they can simply view the status of a particular job. Okay, click on save. Okay, so now let me go to your pipeline. Okay, embeddable build status. Okay, so what I'll do is I'll select the markdown unprotected link. Okay, and then go to your repository, click on markdown readme.md and try to edit it. Okay, simply put this link somewhere. Okay, so I have kept it here. Build status http jenkins:80. Okay, but that should be replaced with the Jenkins actual IP address. Okay. It is copying everything.
You can edit.
Okay.
Yeah.
And that's it. So Jenkins. Okay. And the job name is Terraform. Okay, commit the changes. Okay, it should show some image. Now see, build is passing. Okay, so if I trigger the pipeline, let's say even if you create some changes and then if you try to apply, okay, see there are some changes, that's why a new build is triggered, right?
Yeah.
Okay, now if you go to your repository and then refresh this page, okay, you'll see build is running. Okay.
Yeah.
Let me just cancel this job about this. Okay, now if you go back to your repository, you will see build is aborted. Okay, so what if I create a failure? Let me configure it, and let me simply do one thing. So instead of so let me just make some changes so that those changes are not valid. Now click on build with parameters, manually trigger a pipeline. So this should basically fail, right?
Yeah.
Okay, let's go back to the repository and click on refresh. Okay, currently it is running because it is trying to create the pod and all, but somehow it should actually fail at some stage. Okay, let me go back to the pipeline. Okay, it is still creating the pod. Okay, cloning the Git repository, there is an error, there is a failure. Now if you go back to the repository, you will see that build failing. Got it?
Yeah. Go.
Okay, so this is how you use Jenkins to clone your Terraform configuration and apply the changes.